Hello and welcome to the Bearded Math Man's YouTube channel. Hey, hope this day is wonderful for you. Here's what we're going to do in this video. We're going to be talking about describing end behavior, looking at the degree, looking at a graph. We're going to learn what end behavior is. We're going to learn how to identify it by looking at the degree. And we're going to learn how, end behavior is related to x-intercepts. So let's get to it, shall we? Here we go. You have four graphs right here, right? So let's take a look at number one right here. If you look at number one, this graph is increasing on the left of the graph, the left side of the graph. It's increasing, it's decreasing on the right side of the graph, right? The way we're going to describe the end behavior is this is the end behavior on the far left and on the far right. That's what we're talking about when we're talking about end behavior. The far left and the far right, we're going to say this goes down both ways. Whereas this graph for number 4, if you look on the far left, it's actually decreasing, and on the far right, it's decreasing. So we're going to call this going down, or going up left and going down right. Okay, so it's a little confusing because here we're decreasing, the function's actually decreasing, but the graph itself looks like, if you don't think about if it's increasing or decreasing, up left, down right. Whereas this is up both directions. This one, number 1, is down both directions. This is down left, up right. And number 4 is up left, down right. Down left, up right. Up left, down right. See? We'll get into it. You'll see. We'll get it really carefully. All right, so let's talk about end behavior. Here's what end behavior is. End behavior describes the way that a function's behaving at extreme values of x. So like, for example, off to the left, well, we're talking about really, really small numbers of x. So as x is approaching negative infinity, what's happening to the y's? That's what we're talking about right here. Is on the far left of the graph, is y going down? Or is y going up? That's the end behavior. Whereas on the right side of the graph, as x is getting larger and larger, approaching positive infinity, what's happening to y? Is it going down or is it going up? That's what end behavior is talking about. So we're going to talk about each of these cases separately so that you understand what we were talking about at the very beginning of this video. So it'll be crystal clear. Let's do it, shall we? So let's talk about going to the left. So as x approaches negative infinity, well, this is what it looks like if as x approaches negative infinity, y approaches positive infinity. We're going to say this is up to the left. You see, this is up left because as we go left, that means x is getting smaller. But on this graph, as x is smaller, y is larger. So this is actually decreasing, but we're going to call that up left. Now, let's talk about the left side where the y's are decreasing. That's called down left. So as we go, the x values as the x values get smaller, they go to negative infinity. If the outputs are also smaller, we call that going down left. Okay? Now, what about the other way? So going to the right, as x grows, if y grows, that's going to be called going up to the right. Whereas if we had it this way, whereas we're going to the right, if the graph is going down, we're going to call that down to the right. So this graph right here, if we were going to describe the end behavior of this function, we would say this is down left, because on the left it's going down, and up right. Whereas this one is up on the left and down on the right. So when we describe end behavior, that's what we're going to be doing. Okay? Up left is right here, down right is right here. So down left, up right, and then up left, down right. Yeah. Now, it does get confusing because this is increasing on the left side of the graph. It's also increasing on the right side of the graph. But increasing doesn't really tell you where it's at. So here we're increasing, but we're on the bottom left, and here we're increasing and we're on the top right. Yeah. And same thing here, we're decreasing all the way around. But even so, if we're going to talk about end behavior, we can say this is going up to the left and down to the right. All right, a little counterintuitive there, but that's a good way to describe it. So let's talk about the difference between polynomial functions that have an even degree and polynomial functions that have an odd degree. Even degree polynomials will either go up both ways or they're going to go down both ways. So either they're going to go up left and up right or down left and down right. Whereas odd degreed polynomials, they're going to do opposites. So it's either going to be down left and up right, or up left and down right. Yeah. Because of this situation, odd degreed polynomials will always have at least one x-intercept because they're going in opposite directions on the left and the right. So they are some way or another going to cross the x-axis at least once, whereas an even degree, it might not have an x-intercept at all because, for example, if this one on the bottom right here, if this maximum point was below the x-axis, then it wouldn't have any x-intercepts because it's going to go the same direction both ways. It's either going to go down both ways or it's going to go up both ways, okay? Now, there's an easy way to distinguish between what's going to happen and when. For example, if you have a polynomial and the leading coefficient is positive, well, all you got to do then is look at the degree. If it's an even degree with a positive leading coefficient, it's going to go up both ways. If it's an odd degree, like a cube, or a 5 or 7 or 11, and the leading coefficient is positive, then it's going to go down left and up right. It's going to look like this. Whereas the other way, let's say you have a negative leading coefficient. If you had a degree that was even, like 8, x to the power of 8, but let's say it was a negative leading coefficient, like negative 3, x to the power of 8, it's going to go down both ways. Whereas if you have a negative leading coefficient and the degree is odd, it's going to go up to the left and down to the right. Let's see a few examples of this so we can make it crystal clear, right? So let's say you're given this function, 3x to the fourth minus 2x plus 1, and you're asked to describe the end behavior. Well, first thing you're going to do is you're going to look at the degree. This is an even degree. It's a power of 4, right? So that means it's either going to go up both ways or it's going to go down both ways. To determine which it is, all you got to do, look at the leading coefficient. This one's positive. So it's going to go up both ways. Boom, we're done. Now, what if it was a negative leading coefficient? Well, the degree is still even, so it's going to go either up both ways or down both ways. But now, because we have a negative leading coefficient, it's going down both ways. Do you see? Now, if you have an odd degree, that means it's either going to go down to the left, up to the right, or up to the left and down to the right. One of those two, right? And it all depends on the leading coefficient. Well, here we have a negative leading coefficient, which means it's going to go up left and down right. Whereas if it was a positive leading coefficient, then it would go down left and up right. So there's this fancy little chart right here. You can find these all over the internet. You can just, go to your good old friend GOOGLE, and you could type in polynomial function end behavior, and you're going to get some chart like this. I'll put a link in the description below to my website where you can find some notes and all kinds of stuff, including this chart that'll really help you to understand. But it's a good reference. But play a little game. It's going to be a little fun, and it's going to help it make even more sense. So I'm going to give you a picture. I'm going to say, hey, this picture represents some polynomial function. I want you to tell me if the degree is even or odd, and I want you to tell me about the leading coefficient. So let's talk about John Travolta in Saturday Night Fever. Let's say his arms are mimicking the graph of a polynomial function. I want you to decide, is the degree even or odd? Go ahead and take a guess. Is the degree even or odd? Well, it's odd because they're going opposite directions, right? His hands, which would be like the end behavior on the left and the end behavior on the right, are going in opposite directions. So that's going to be an odd degree. And how about the leading coefficient, positive or negative? Well, from the way we're looking at it, this being the left side and this being the right, it's going up to the left, down to the right. That is a negative leading coefficient. So it would be something like f of x equals negative x to the power of 3 plus who even cares? All that would matter is that the leading coefficient is negative and the degree is odd. There we go. What if it was this way, though? What if we had a different answer and, it's the other way around? Well, it's still going to be an odd degree because the ends are going in opposite directions, but now because we're going from left to right, we're going up, so it's down to the left and up to the right. That's going to be positive. So we have an odd degree, so 3 would still work. With the leading coefficient now would be positive. What if it was, the Village people doing the YMCA song? What would these graphs possibly be? The degree even or odd? Coefficient, positive or negative, leading coefficient. Well, since they're going the same direction both ways, that means that it's not odd. It's going to be even. And since they're going up, it's positive. There we go. So I hope this has been helpful. If it has, give it a thumbs up. You can subscribe, share. Man, get the word out there. If this is helpful, I would like to help lots of people. And on my website, I will leave a link in the description below. You will find all kinds of stuff on polynomial functions, all kinds of other fantastic and wonderful math topics are covered there. And so check it out. Make sure you read the notes. This is a screen capture of a different lesson on increasing or decreasing functions. But you can read the notes, you can watch the video, you can try the practice problems, you can leave me a note in the bottom of in the comments down below. I would love to be able to help you out or just hear from you. I hope you guys are all doing well. Today is April 14th, 2020. So we're in the middle of staying sheltered from the coronavirus. I hope you guys are all practicing social distancing and are safe and sane and happy and healthy. And I hope to get to see those of you who are my students. I hope to get to see you in person very soon. Until then, I hope you have a great day.